27,000 comments. That is what the last rocket mass heater video pulled in. And after reading through every single one of them, there are 5 questions that kept showing up over and over from people who watched the full build, understood the physics, believed the numbers, and still could not pull the trigger. Not because they doubted the stove, because they doubted the system around it. Will my insurance company drop me? Is this even legal in my county? How do I size one for my house? Can it actually be my only heat source? And what about the batch box? Is that the real version of this? Those are not beginner questions. Those are the questions of someone standing at a hardware store, credit card in hand, who needs one more answer before they start cutting steel. So here is the deal. This video answers all 5. With codes, with data, with names, with numbers, no filler, no hedging, no do your own research. This is the research. That is not an accident. The reason these 5 questions exist is not because the information is complicated. It is because the information is scattered across 400 forum threads, a dozen outdated PDFs, and a handful of YouTube videos where someone built one in a shed and never followed up. Meanwhile, the heating equipment industry in the United States generates over $30 billion a year. The average American household spent $976 on heating in the 2025 to 2026 winter season alone. Propane households spent over $1,200. Heating oil households over $1,300. A rocket mass heater, built from fire brick, a steel barrel, and cob, heats the same space on 1 to 2 cords of firewood per season. A cord runs $250 to $400 delivered, depending on your state. If you have trees on your property, it costs nothing. So why is this design not in every off-grid catalog, every homesteading manual, every building supply store? Because a heating system that costs $40 to build lasts decades, burns 90% less wood, and requires no service contract is a terrible business model. The confusion around codes and insurance is not organic. It is convenient. You already know the answer. Here is where it gets interesting. The first question, and the one that stopped more people than any other, is safety. Specifically, carbon monoxide. Will this thing kill me in my sleep? That exact phrase showed up in the comments more than you would expect from adults who presumably operate gas stoves and fireplaces every winter without existential dread, but the concern is real, and it deserves a real answer. A properly built rocket mass heater with a functioning draft produces almost no carbon monoxide. The combustion temperature in the burn tunnel exceeds 900 degrees Celsius. At that temperature, wood does not smolder. It gasifies. The volatile organic compounds that would normally escape as smoke and carbon monoxide in a conventional fireplace are instead burned as secondary fuel. The exhaust coming out of a well-built system is primarily steam and carbon dioxide, with carbon monoxide levels measured in single-digit parts per million. For comparison, a standard open fireplace produces between 100 and 400 parts per million of carbon monoxide at the flue. A modern EPA-certified wood stove produces 20 to 60. A natural gas furnace with a cracked heat exchanger, the kind sitting in millions of American basements right now, can dump 200 plus parts per million directly into the living space with no visible warning. The rocket mass heater is not the dangerous outlier in this lineup. It is the cleanest burner on the list. But, and this is important, the classic J-tube rocket mass heater has an open feed tube. That means the combustion chamber is open to the room. In an older, drafty house, this works fine. The house leaks enough air to feed the fire and maintain a strong draft pulling into the burn tunnel. In a modern, airtight home with an HRV system or a kitchen range hood, you have a problem. Negative pressure inside the house can reverse the draft. Instead of pulling air into the burn tunnel, the system pushes combustion gases out through the open feed tube and into the living space. That is where carbon monoxide becomes a real risk. The fix is either a dedicated external air intake plumbed directly into the combustion chamber, or a batch box design with a sealed loading door. The Liberator rocket heater, built in Missouri, is currently the only commercially manufactured rocket heater that is UL 1482 certified, ULCS 627 certified, and ASTME 1509 certified. It comes with an external air intake port built in. It heats up to 2,000 square feet. It burns wood and pellets at roughly 99.5% combustion efficiency. Regardless of what you build, install a carbon monoxide detector. Not because a rocket mass heater is dangerous, because you are burning wood inside your house, and every combustion appliance deserves a $10 safety net. That is common sense, not a design flaw. The second question, building codes. Is this legal? The short answer is, it depends. And that is not a cop-out. It is the actual jurisdiction by jurisdiction reality. Rocket mass heaters do not have a dedicated code category in the International Building Code or the International Residential Code. They are not listed. They are not banned. They exist in a regulatory gap. What does exist in code is the masonry heater, ASTME 1795, the Finnish masonry stove, the Russian pechka, the Swedish kakelugn. These are all code-recognized designs with established clearance requirements, chimney specs, and inspection protocols. A rocket mass heater with a brick or stone thermal mass, properly insulated flue, and appropriate chimney is functionally a masonry heater. Many jurisdictions will permit one under that classification, especially if you can show the inspector a set of drawings that reference ASTM standards. 47 U.S. jurisdictions now explicitly regulate thermal mass heating systems. That number has increased significantly in the last 5 years. Some counties will require an engineered drawing. Some will require a site inspection. Some, particularly rural counties with less than 50,000 residents, will wave you through with a basic wood stove permit. Here's the cheat code that nobody talks about. If you install a UL-listed unit like the Liberator, most building departments and insurance companies treat it exactly like a certified wood stove. No special permits, no engineer, no gray area. The UL listing does the arguing for you. If you want to build your own from scratch, which is the whole point of this channel, there are 3 paths. Path 1, build it in a detached workshop, garage, or outbuilding that is not classified as a dwelling. Many jurisdictions do not require heating permits for non-residential accessory structures. Path 2, build on rural land where permits are not enforced or are handled through a simple application. Path 3, work with your local building department directly. Bring drawings. Bring the ASTM 1795 standard. Bring photos. Bring this video if it helps. The worst thing you can do is build one without telling anyone, and then have a chimney fire that your insurance company uses to deny your claim. That is not a risk worth taking, because this channel always gives you the full picture. Question 3. Sizing. How big do I build it for my house? This is where people overcomplicate things. So here is the simple version first, then the detailed version. The simple version. For a 6-inch system, which is the most common DIY size, you are looking at comfortable heating for 400 to 800 square feet. An 8-inch system covers 800 to 1500 square feet. Beyond that, you either need a very large system or 2 smaller ones placed strategically. The detailed version. Heating capacity depends on 4 variables: insulation quality, climate zone, thermal mass volume, and burn duration. A standard rule of thumb for residential heating is 20 to 30 BTUs per square foot per hour in a well-insulated home, and 40 to 50 BTUs per square foot in an older or poorly insulated home. A 6-inch J-tube rocket mass heater burning dry hardwood produces roughly 30,000 to 40,000 BTUs per hour during active burn. An 8-inch system produces 50,000 to 77,000 BTUs per hour. But here's what makes a rocket mass heater different from every other wood stove. You do not burn it all day. You burn one hot, fast fire for 1 to 2 hours. The thermal mass, which can weigh between 1 and 3 tons of cob, brick, or stone, absorbs that heat. Then it releases it slowly over the next 12 to 18 hours. That means your actual heating capacity is not just about BTU output during the burn. It is about total heat stored in the mass and the rate at which that mass radiates into the room. A 3-ton cob bench with a well-insulated core can hold enough thermal energy from a single 2-hour burn to keep a 1,000 square foot, well-insulated space above 60 degrees Fahrenheit for 16 hours in 20 degree Fahrenheit outdoor conditions. If you live in a climate zone 6 or 7, where temperatures regularly drop below 0 Fahrenheit, you will likely need 2 burns per day, morning and evening. Each burn uses roughly 15 to 20 pounds of wood. That is about 1/3 of what a conventional cast iron wood stove burns for the same heat output. If you're in zone 4 or 5, where winters are cold but not brutal, 1 burn per day is often sufficient. The mass holds enough residual heat overnight to keep the space above 55 degrees by morning. You light the fire with your coffee, and by the time you leave for work, the mass is charged for the day. The most common mistake in sizing is not undersizing the heater. It is undersizing the mass. A 6-inch system connected to a 50-pound barrel and nothing else will heat a room fast during the burn and then go cold in 4 hours. The same 6-inch system connected to a 1,500-pound cob bench will heat the same room for 14 hours on the same amount of wood. The burn tunnel determines how hot you burn. The mass determines how long the heat lasts. Most failed builds have adequate burn tunnels and inadequate mass. 1 cord of hardwood weighs roughly 4,000 pounds. At 30 to 40 pounds per day for a rocket mass heater, 1 cord lasts between 100 and 133 days. A full heating season in Zone 6 is about 150 days, so call it 1.25 to 1.5 cords per season. At $300 per cord delivered, that is $375 to $450 per year. At $0 per cord, if you cut your own from standing dead timber on your property, that is free. Compare that to $976 average for the national heating bill, or $1,210 for propane, or $1,390 for heating oil. Over a 30-year mortgage, the math becomes difficult to ignore. $976 times 30 years is $29,280 in heating alone. For propane households, it is $36,300. For heating oil, $41,700. A rocket mass heater burning 1.5 cords per season at $300 per cord is $450 a year. Times 30 years, $13,500. That is a difference of $15,000 to $28,000 over the life of a home. And that is before you factor in that the heater itself costs $40 in materials and has no moving parts, no service contract, no annual inspection fee, and no expiration date. The numbers are not subtle. Question 4, the one that made this video necessary. Can I use this as my only heat source? Yes, with conditions. Thousands of people across the northern United States, Canada, Scandinavia, and Eastern Europe heat their homes exclusively with thermal mass systems. This is not experimental. Masonry heaters have been the primary heat source in Scandinavian and Russian homes for over 500 years. The rocket mass heater is the same principle, built cheaper. The conditions are these. First, your home must have reasonable insulation. You do not need a passive house. You need walls, a roof, and windows that are not actively hemorrhaging heat. If your house has single-pane windows from 1962 and no attic insulation, fix those first. A rocket mass heater cannot outrun a sieve. Second, you need a backup. Not because the system will fail, but because you will. You will get the flu. You will travel for a week. You will have a morning where you do not feel like hauling wood at 5 a.m. in 11-degree weather. A small electric space heater, a propane wall unit, or even a simple electric blanket gives you that safety net. Primary heat does not mean only heat. Third, location matters. The thermal mass needs to be in the living space, not in a basement, not in a garage, not in an attached shed with a closed door. Heat radiates in line of sight. If the mass is in the living room is warm. The bedroom down a hallway with 2 closed doors is not. For open floor plans under 1,500 square feet, a single 8-inch system with a heated bench running through the main living area is the standard recommendation. For larger homes or compartmentalized layouts, 2 smaller systems or a system with a long exhaust run through multiple rooms is the play. And here's the part that surprises most people. The heated bench is not a gimmick. It is the entire point. A cob bench running 8 to 12 feet along a wall with the exhaust ducting embedded inside turns the thermal mass into furniture. You sit on it. You sleep next to it. You lean against it while you read. The surface temperature stays between 80 and 110 degrees Fahrenheit for hours after the fire goes out. In Scandinavian and Russian tradition, the heated sleeping bench was not a luxury. It was how families survived. That is the bridge to question 5, the one the experienced builders have been waiting for. The batch box. The classic rocket mass heater uses a J-tube burn tunnel. Fuel is fed vertically through an open tube. The fire burns sideways at the base. Gases rise through an insulated riser, hit the barrel, reverse direction, and flow through the thermal mass before exiting the chimney. It works. It has worked since Ianto Evans and Larry Winiarski codified the design in the 1980s. But it has a limitation. The open feed tube needs tending. You feed sticks in every 15 to 20 minutes. You cannot load it and walk away. For some people, that ritual is the whole point. For others, it is a deal breaker. The batch box, developed primarily by Peter Vandenberg in the Netherlands, is the answer. Instead of a vertical feed tube, you have a firebox, a door. You load it with split wood, close the door, light it, and walk away. One load burns for 1 to 3 hours depending on the box size and wood type. No tending, no open flame visible in the room, no sticks rolling out onto the floor. The combustion efficiency is comparable. Some builders argue it is higher because the sealed environment allows better control of the air-to-fuel ratio. Others argue the J-tube, when properly sized and operated, achieves the same temperatures with less complexity. The Permies community has been debating this for over a decade. The consensus, if there is one, is that both work. The batch box is more convenient. The J-tube is simpler to build and more forgiving of beginner mistakes. For a first build, the recommendation from nearly every experienced builder is the same. Start with a J-tube, build it outside, run it for a season, learn the draft, learn the feed rate, learn what dry wood sounds like versus wet wood. Then, if you want the convenience of load and leave, convert to a batch box or build a second system using Peter Vandenberg's published dimensions at batchrocket.eu. The 6-inch batch box is the largest size recommended for use with a piped thermal mass. For a Bell-style mass, you can go up to an 8-inch batch box. The BTU output of a 6-inch batch box is calculated at roughly 77,000 BTUs per hour. That is enough to heat most well-insulated homes under 1,500 square feet with a single burn. One more thing the comments kept asking about. Hot water. Yes, you can integrate a hot water coil or a water-jacketed barrel into a rocket mass heater system. Builders on the Permies forum have documented setups where the exhaust run passes through or around an insulated water tank, preheating domestic hot water as a byproduct of the heating burn. This is not theoretical. This is how Russian Pechka systems have worked for centuries. The exhaust heats the mass heats the bench, and somewhere along that path, a water jacket or coil pulls off enough thermal energy to give you 40 to 60 gallons of hot water per day. The engineering is straightforward. The execution requires attention to pressure relief and freeze protection. Do not skip the pressure relief valve. Do not use plastic fittings anywhere in the hot zone. And if you live where it freezes, drain the system or use an antifreeze loop. These are not optional suggestions. They are the difference between a functional system and a burst pipe at 3 a.m. in January. Here is the part that stays with me. 500 years ago, a farmer in Finland built a soapstone stove the size of a wardrobe. He burned 1 armload of birch in it every morning. The stones stayed warm until the next dawn. His grandchildren did the same thing, and their grandchildren after them. That stove is still standing in some of those farmhouses, not as a museum piece, as the heater. The design migrated to Sweden, to Russia, to Norway, to every cold climate culture that figured out the same elegant truth. You do not need to burn wood all day to stay warm. You need to capture the heat from one short burn and release it slowly. Somewhere in the 20th century, that knowledge stopped being taught. Not because it stopped working, because there was no profit margin in a stove that lasts 100 years and burns almost no fuel. 27,000 comments told me something. The knowledge is moving again. You are moving it. Every comment, every question, every build photo dropped in the thread below is one more data point that the heating industry cannot bury. You now know what a $30 billion industry depends on you not knowing. If this answered even one of your 5 questions, send it to the person who asked you the same thing last week. You know who they are. This channel exists to dig up the knowledge that got buried when it stopped being profitable to teach. If that sounds like something worth protecting, subscribe, not for the algorithm, for the archive. Thanks for watching. I will see you in the next one.